Okay, so welcome to the third video on naming and properties. We're going to go over today is just touch on haloalkanes, alkanols, and amines. We'll just quickly go over stuff that we should know, and we'll just point out a couple of things that might extend what we already know about how to name these molecules. So alkanols, as we know, sorry, haloalkanes, we know that we can generally just show them represent them as just an X in general attached to a carbon, but usually the X is either a bromine, a chlorine, a fluorine, or an iodine, and that's what makes a haloalkane. Is basically any halogen attached to a carbon is a haloalkane. They usually have the prefix or the start of when we name them, the starting bit of the name is either chloro for chlorine, bromo for bromine, fluoro for fluorine, iodo for iodine if you ever have to name that. So here's an example here. We know that the bromine takes precedence to the methyl group. So here when we name this, we get the longest chain, and we would get the numbering starting from the bromo here, or from the bromine. 1, 2, 3, 4, so it would be 3 methyl. We'd name the bromine first to put it in alphabetical order, so it would be 1 bromo, 3 methyl butane, and there we go. Okay, so that's haloalkanes. Alkanols, how do we name those and what are they? Well, we remember they're just alcohols. Alkanols just a fancy name. It's an OH group attached to a carbon on a carbon chain, but remember it's not an OH group when the carbon also has a double bond oxygen on it. That would then be carboxylic acid, so it has to be only an OH coming off the carbon. Generally they're represented, sometimes you might see just ROH if you have a general formula, and an R means any length of alkyl groups. A CH3 group, CH3, CH2 group, etc., etc. I just sort of chuck that in for a bit of flavour. Here is an alcohol here. So if I just go over quickly, if we want to name an alcohol, remember it's just a suffix or it's an end part of the name. It's ol, we replace the E with an ol, and then we put the number it's attached to in front of it. So we would have something like butan 2-ol or pentan 1-ol. In this case though, if we have two of them like we do here, of course these OH groups are going to have preference to this methyl group here, so we're going to number from the right. Longest chain is a pentane, so we're going to go 1, 2, but because there's two of them at the end, it's now going to be 1,2-diol. So we've got 3,3-dimethyl, two methyl groups, pentan 1,2-diol. One thing we might not have learnt though is it's actually with many of these functional groups, and particularly alcohols, is you can also name them with the prefix instead of the suffix. And the prefix for these is hydroxy or hydroxyl. So I'm going to name this now a different way. So we're going to just keep the pentane at the end, but I'm going to put these at the start. And these groups are called hydroxyl groups. So now we're going to have 1,2-dihydroxy. Okay, 1,2-dihydroxy, 3,3-dimethyl pentanol. And this is how we could name it a different way. Usually we'll see them named that way. You might see them sometimes written down like that. If you see this hydroxy, then what that means is it's an alcohol. Classifying alcohols and haloalkanes. Okay, so basically we can classify them as primary, secondary, or tertiary. You might already know how to do that. However, we're not actually classifying the molecule when we do this. We're only classifying the functional group. So here we would classify the bromine functional group. We would look at what carbon it's attached to, and then see how many carbons are attached to that carbon. In this case, this carbon has one attached to it. So this is a primary functional group. In this case here, the chloro group has a carbon that is attached to has 1, 2, 3 carbons attached to it. So this is a tertiary classification. these two functional groups have different classification. This OH is attached to a carbon that has one carbon, so it's a primary. And this OH is attached to a carbon that is attached to two other carbons, so it is at a secondary classification. So if you ever need to classify, and often we would classify a molecule because a functional group that is a tertiary functional group may react different to a functional group that is a primary. And that's the reason why we classify alcohols or haloalkanes. If we want to identify alcohols, and this is an example of why it's important to know whether they're primary or secondary, then both primary and secondary alcohols will react with acidified dichromate, which is an orange color. It goes green when it reacts, or acidified permanganate, which is a purple color, and it goes colorless. So notice here that when we react with permanganate, permanganate is an oxidizing agent, so it is going to oxidize the alcohol here to a carboxylic acid. In fact, it has an intermediate in between where it becomes an aldehyde and then goes to a carboxylic acid. We could also use the dichromate, where if we have a primary alcohol, we could see that what we came up with was a carboxylic acid. If we have a secondary alcohol, we don't produce a carboxylic acid. We can't, because the OH is not on the end of the functional group, and that change can only happen to the point where it is attached. So in this case, it becomes a ketone. Now remember, at the top here, you could use permanganate or you could use dichromate. And the same at the bottom, you could use the dichromate or the permanganate. Tertiary alcohols. If we want to identify tertiary alcohols, what we can do is we can do something called the Lucas reagent or the Lucas test. So Lucas reagent is basically a mixture of concentrated hydrochloric acid and zinc chloride. The zinc chloride acts as a catalyst. If we add this solution to tertiary alcohol, so this is a tertiary alcohol, it will go cloudy quickly. Now the reason it goes cloudy is this haloalkane, for a start, this alcohol here, usually a tertiary alcohol, when it's in the water is in a cloudy solution, but as soon as we get to this solution here, it becomes cloudy. So we add 5 drops of the alcohol to the Lucas reagent, shake and observe. If the solution goes cloudy, a tertiary alcohol is present. If the solution does not go cloudy, we put it in a heat source, like a water bath, at 30 degrees for 5 minutes. If the solution goes cloudy after that 5 minutes or after that time, then it's most probably a secondary. If it doesn't go cloudy, it's just a primary. Okay, so this is a secondary alcohol. When we add the Lucas reagent, will go cloudy after 5 minutes and heat. Amines. So amines are a functional group. NH2 functional group is attached to a carbon. So that's what an amine is. We can actually classify amines as primary, secondary, or tertiary as well, but a primary, secondary, or tertiary amine is different type of classification than we did with alcohols or haloalkanes. So that with amines, it's really about how many carbons are attached to the nitrogen, not to the carbon. So this amine here is classified as a primary amine because the nitrogen has 1 carbon attached to it. It doesn't matter that the carbon the nitrogen is attached to is 2, it's how many carbons are attached to the nitrogen. This is a primary. A secondary amine then has 2 carbons attached to it. And a tertiary has 3 carbons. So when we classify amines, if you ever see amines you need to classify them, remember they are classified by how many carbons are attached to the nitrogen. Amines, when we name them, we use the prefix amino, just like we use the prefix chloro for chlorine, we use amino for amine. And we put a number in front of it to say which carbon it's attached to. So if this is our amine here, this is obviously attached to the second carbon, so it will be 2-amino propane. And I've written down 2-aminobutane. Well, let's just ignore that. Okay, how do I identify amines? Well, because amines are, amines have a sort of ammonia-y, sort of fishy smell. Tertiary amines really smell kind of like fresh fish. All amines are weak bases. That means that if we put them into an aqueous solution, they will form an alkaline, and so therefore they will neutralize acids, or we can test them with just something simple like litmus paper. So here, if we add an amine to water, you can see that the water will donate a proton to the weak base, that is the amine, and we're left with some hydroxide ions. Hydroxide ions are basically our base solution. So we add some water to our amine, we produce a base solution, and then if we put litmus paper in, red litmus, it will go blue. So that's how we test for